So the idea here was to just go through some of the things that are new and recent in GPIO. And then I had one quick item I want to talk about with pin control. So let me see how, okay, I can advance them now. I pasted into the Slack as well the link to the slides there if people want to be able to click on them. So for people that haven't seen these talks in the past, these are good references from Linus and Bartosz. Most importantly, the last one there was from back at the end of June for the Embedded Linux conference, and has content that we're going to be talking about today. And that slide there is from Bart's talk. So before we jump into the user space API GPIO changes, I think one thing we should bring up is the GPIO aggregator. So this is a neat feature that Gert worked on earlier this year. I'm not sure what kernel got merged into, but it was, I think, earlier in 2020. So this is quite an interesting feature for where people want to be able to expose several GPIO chips as one virtual GPIO chip. And one of the reasons would be for access control, so that you can take different GPIO lines and combine them into a virtual GPIO chip and then set the permissions that you want in there. I think there's some other interesting use cases for it as well. So I don't know if anyone wanted to chat about this one. If not, we can get into the user space API changes. Bart, did you have anything you wanted to add about this one, or anyone have any questions?
So this is something that maybe we could talk about later when you're done with your slides, but I wanted to bring up the config.fs for GPIO mockup that I'm working on. And I was thinking that maybe using sysfs for GPIO aggregator wasn't the best idea, because I think now having learned more about config.fs, I think it would be better to use config.fs to instantiate the aggregated chips. But yeah, we went the sysfs route, so we're probably stuck with that. But
okay.
I will talk a bit about what I'm doing for GPIO mockup for the testing module with config.fs. But we can do it later, like when you went through your slide.
That should work. Let's see here. So, I see we have Linus as a panelist, but I think he's still muted now. So I think hopefully that's on purpose.
I can unmute.
Okay, awesome. So the next topic was the current state of the uAPI, user space API. So in general, and I think if you watch any of the previous talks, the idea here is that you should be using subsystem drivers for using GPIO when you can, but there are certain use cases where that's not feasible or a good idea. And Linus added earlier this year, I think back in January, some documentation about using GPIO lines. So that's a good thing to check out if you're also trying to convince people that want to maybe do things that they shouldn't. That's a good thing to refer people to. It's now in the kernel documentation. Of course, the legacy user API here is the sysfs, and then as of Linux 4.8, which is actually quite a while ago now, we now have the character device where the GPIO chips show up as character devices. And then features that were added recently to the existing version 1 user space API for the character device. There's been a few things that were added this year, including the bias settings. So there was a desire from user space libraries to be able to do pull up and pull down through the character device. And Kent Gibson worked a lot on adding this feature along with Bart and Linus. And then another thing that was part of that change was a set config iactl or IO control. And that allows people to be able to change the configuration while they're still owning the line. So rather than closing it and trying to open back up, there's no race condition there. And then also the ability to watch lines from user space. However, the real story here is the new version, the V2. So from Bart's slides at ELC, one of the examples he brought up with an issue is the idea of 64-bit kernel with 32-bit user space. And this is where the size of the struct is different depending on the architecture. And the other issue is that we didn't have padding in the struct to add new features. Things came up like debounce on the mailing list, and that wasn't really possible. So along came the V2 of the character device user space API. This is still an active patch series. So the most recent version, version 9, was posted this week by Kent. The idea here is to add in the padding that's needed to make it more future-proof. And then also some of the features were refactored a bit to make it easier to work with. So one of those, and this is from Bart's slides there from ELC earlier this year, is there used to be line handle and line event, and now those are all just line request. And the flags are reworked now too to make a little bit more sense. So this is the patch series. So there's a lot of little things in there, but probably one of the bigger ones is the patch number 4, which defines the user space API and kind of goes into some details there about the things that have changed. I don't know if Linus or Bart, do you wanted to add anything here, or if anyone has any questions?
I mean, the first thing like somebody asked me on IRC or something like, what's up with the micro API? And that's a common misunderstanding. It's the user space API. Like I want everybody to know that, because that's what we mean with the kernel. So maybe it's a bit unlucky with that we don't write this all caps. Okay. It confuses some people. So for the audience and everyone, it's the user space API. And the other thing is then I got some flack from some people which will remain anonymous on like, don't you guys ever make your mind up about how things are going to work? And I think my rebuttal to that was a reference to the quite well-known book in management called The Mythical Man Month, which states explicitly always calculate to throw one iteration away. The first version is going to go. That's just how it works. So
yeah, no
this
plan
what is happening to us. Yeah, this is exactly what's happening to us, and it's to be expected. So like I understand the perfectionism, but that's not what we are doing. We are doing rough consensus and running code. That's the IETF motto, and that I think should be our motto as well. I think we're doing just fine.
Yeah, no plan will survive the contact with the enemy.
Great. I see Andy joined the chat as well. Andy, if you can hear us, if anyone raises their hand, I should be able to see that and I can allow them to speak. All right, so actually the next one is about pin control, which is kind of a discussion if we have time that I wanted to bring up. But I think the biggest thing going on here is the new user space API. I don't have a slide for it, but I don't know, Bart, if you wanted to get into what you're talking about with config.fs, or if anyone has any questions or comments thus far. We have about 15 minutes left, so should have enough time for discussion.
I can talk about GPIO mockup and user space testing and config.fs if nobody else is waving their hands. Probably not. Okay. So we have, like the user space API is actually wrapped in this library that we have, which is called libgpiod, and this is like it's basically a wrapper around the bare ioctl calls, which makes things easier. And in the package, there are some user space tools, and this library has a test suite that is based around a kernel module, which is called GPIO mockup, which basically allows us to create simulated GPIO chips and test both the library and the user API. And we've actually found a couple of bugs with this testing tool, so it's quite useful. And right now, the testing module in the kernel uses debug.fs to control the chips and uses module params to instantiate chips. So basically, we're very limited in that we have to always unload the module, load it again to create a new set of chips. It's quite, it isn't very extensible, because in order to add new flags and new features, you would have to add new module params. And so I tried to create a better debugfs interface for that, which would parse the command line, which would parse the input and for arguments and create chips on the fly without having to unload the module and load it again. But I was told that actually the correct tool to use in this case would be configfs and sysfs, like they go together. And I was vaguely aware of configfs's existence, but I didn't know it very well. So now that I spent some time learning it and just getting to know how it works, I think it is the right tool to use. And for those who don't know configfs very well, it's basically the opposite of sysfs. So sysfs represents objects that are created in the kernel, and configfs allows you to create kernel objects from user space. Basically, you tell modules, make me in our case, we would just tell the kernel to make me a GPIO chip with this and this configuration. And the thing with configfs is that the feature that we really need for GPIO mockup, that is so-called committable items, is not implemented yet. It's well defined in the documentation, but it's not implemented. So I started implementing it with the aim of using it for GPIO mockup. And now that I got to know configfs pretty well, I'm sorry, this is my kid hitting the door. Now that I learned configfs, more about configfs, I think this could have been the right tool to use for GPIO aggregator, because it would be quite useful to call mkdir in some configfs directory to create an aggregator, then write to all the configfs attributes to configure the chips that should be aggregated and their lines, and then commit this item by doing the rename to the live directory. Like, this is all in the configfs documentation. I probably sound quite chaotic, but this is how configfs works. And yeah, so that's it. I see that Gert joined us, so yeah, maybe he's probably he knows the aggregator better, so maybe he could speak his mind on it.
Yeah, Victor, if anyone wants to speak, like Gert, or I saw Andy, who's another person that's very active in GPIO, if they want to speak, are we able to give them the mic?
Yes, absolutely.
So I think Gert is in here as well. I don't seem to have the ability to do that, but
okay.
yeah, if anyone wants to.
Who do you want me to give the mic?
I don't know if Gert has anything to say, but he's the person that did the GPIO aggregator.
Okay.
I just see chat next to his name, but if he wanted to say anything here. And Bart, I didn't know if you had any like graphics or anything you wanted to share. I can give you the screen, or if it was just
not really. I'm not really prepared to present anything.
Okay.
I just thought that this configfs thing is nice. So probably not for this release cycle, but for the next, I will send a series that implements the committable items for configfs, and then I'll reuse them in GPIO mockup. This is my plan for testing, and by then we should already have V2 in upstream. So yeah, it's probably going to go together.
Okay. And I didn't actually put it in the slide, but if there's people that are kind of new to GPIO or pin control, kind of the main place to look is the mailing list that you'll find listed on Lore. And the links in the slides go to that. There's the GPIO subsystem mailing list, which is probably the best way to keep in touch with what's going on. And if no one else had any other comments or thoughts right now, I can go on to the one kind of question I had regarding pin control. We have about 10 minutes left. If there's anyone that wants to speak, maybe put it in the Zoom chat, or I'm also watching the Slack as well. All right, let me. I'll
I
move
think like
along.
one thing that I would like to know is from Gert if he can say something about the future for the aggregator. If like where is it finished, or is there like a lot of work that needs to happen? Are you seeing future use cases, this kind of stuff? That would be really interesting to know.
Do you hear me?
Yes.
Yeah, we hear you.
Okay,
Absolutely.
good. So, well, the original idea behind the aggregator was to expose GPIOs to a virtual machine. And that goal has been reached. So as far as I'm concerned, it's finished. In the meantime, a few other use cases popped up, like using it as some generic GPIO driver for, the example I gave in the documentation was for a door lock that's controlled with the GPIO. Then I think it's better to keep it separate from the mockup driver, because those are two completely different things. Like Andy also said, the aggregator is a bit simpler when talking about configuration, because it basically takes just a list of GPIOs and that's it. While with the mockup driver, if I read what the plans are there, then lots of configuration options will be possible.
I fully agree. Definitely didn't like the idea of putting them together.
Oh yeah, it was Andy who suggested to putting it together, but it's well, and the reason I didn't use config.fs is because it's basically, well, creating a new aggregator device is a quite simple operation, and in many other drivers and subsystems you already have this new device sysfs file, and since it's just one line you have to write to that, I don't think you need more configuration. There's one thing that perhaps you want to configure. Let me look it up. Yes, so right now you can, the aggregator forwards everything to the original physical GPIO, which means that you can completely reconfigure a pin. And perhaps that's something we may want to block. For example, if you have configured, I'm sorry?
No, I was asking, what do you mean by completely reconfigure?
Well, if you put the direction in DT, you can still override it from the driver or from user space and things like that. So if you put so
it's like a bit of policy that might want to add to the aggregator to like restrict what it can do with the underlying GPIO lines.
Yeah, that's right. So right now from user space, you can configure input, output, whatever. While if you describe your door opener device in DT, for example, then these GPIOs are configured as outputs. And then from user space, you could still change them to input, or vice versa. Yeah, from output to input is not that dangerous, but the other way around, you could damage some hardware, for example, if you suddenly drive an input with a signal.
That sounds very useful to be able to set a rule like that.
Yeah, I had a quick look already if there are some special flags in the GPIO subsystem that we can see if direction has been configured from DT or not, but that doesn't seem to be the case.
We don't have any policy as of today. What I know, we are more like counting on the device tree to be kind of static, and but the kernel space can of course already change this around. So we have no way to, in any of the hardware descriptions, to say like this pin or this line is for output or input only. The driver can implement it. It can refuse to execute the set direction call, of course, to input or output. So we can have a limitation down on the hardware level, but we can't configure that limitation, let's say, from the device tree or as something per device specific. It's only something that would be a property of the hardware itself. There is hardware with output lines that are only output or input lines that are only input, and we can handle that in the driver, but there's no way to add that policy on top of something that is electronically speaking or register-wise multi-direction.
Okay.
So Drew, do you want me to talk about pin control?
Yeah, we just have, I think, a few minutes left here. One of the things I've been wondering about was for kind of a debugging or development type use case was the ability to change a pinmuck state. The motivation here for me is currently with the Debian image that we ship on the BeagleBones. We have an out of tree driver, MISC driver, that allows people to have, there's a state file in sysfs which allows them to change the state for the pinmucks on a pin. So this is meant for like people doing rapid prototyping where they want to switch between like PWM to GPIO. And those are all defined in the device tree. It's just a matter of doing the pin control select state during runtime on it from user space. And I'd like to get rid of this out of tree driver and trying to have some sort of mainline solution. I think back during ELC, you'd mentioned that debugfs might be one way to do it. And I chatted on the list a little bit about it, and Tony had mentioned, I think he thought putting it into the generic pin control might be one way of doing it, or the driver in this case is pin control single. So just kind of wondering what you or other people might think about the solution for this.
Yeah, the basic problem you're going to run into here is the device tree overlay people, and I just have no control over these people. That might sound a bit, you know, off-putting or derogative, but it's just like such a big, it ties into this system device tree and, you know, all this kind of discussion that people are having, and I just simply cannot grasp that thing. I just have to give up and toss up my hands, and it's like, yeah, you go fix it. I mean, I can't figure out the whole world of system device tree, and it's also typical that this is one of the first things that we see, because with the introduction of device tree to begin with and the evolution of it, what is the first thing that people always do with their device tree is always pin GPIO and pin control. Like, for some reason, this always comes first in their mind, not even LED, always GPIO. So it's a bit stressful that we as kernel developers, I suppose, if I talk about, I am like the in-kernel representative of GPIO and pin control, and Bartos might be the user space interest party. We are kind of hijacked or something into this kind of system-wide description discussions, and that universe is just so big that I just have to give up sometimes. Of course, we can add a facility in debugfs. Debugfs is not a stable ABI, so it may break tomorrow. Right. It might be something AM3358 specific. Let's say that it only works with that thing ever, but that might be okay for you. I don't know.
Yeah.
As for
so
generic solutions,
yeah.
that's another thing.
I've been playing around with both solutions, and one is I could add like a select state file to the main debugfs entries in core, or I could do it in the driver. Is either one seem more appropriate to you?
Yeah, that's a good question. I would say start with the driver, and then let's see if there is generic interest, and then evolve it into core, though that will be like a lot of more work.
Right.
Like I kind of like that gradual approach to it, like solve the problem that you have, And then if it turns up somebody else has that problem, then you start to generalize it. Otherwise, we get the upfront design pattern, like big upfront, build a skyscraper in New York, kind of things, and that just takes too much time.
Okay.
Guys, do you hear
Yeah,
me?
so
Okay, it's Andy. I would like to add to the topic that we used to have something like specific debugfs interface for stock image for these IoT projects from Intel. And it seems people used really differently. So the idea was because we have firmware and firmware misconfigurates sometimes pins. We would like to configure them back at runtime, but I think this is not what actually we need, because either in device tree or in ACPI we could just, you know, reboot system. It's like only matter of 1 minute. So why do we need to have it at all at runtime?
That's where it come. We get this thing that I talked about for the Beagle specifically. What people are pointing at is system device tree. If this was like an Intel board, they would be pointing us to ACPI DSDT, I guess, and say like, yeah, well, just change that or just change this. And the problem there, which is not like which is a device tree universe specific problem, is that they just don't have the infrastructure to do dynamic updates to device trees. I mean, they might have it in some form. You might be able to do it in the bootloader, but doing it at runtime on a system that's up and running, that's not working for them. And it's not doable to make it at runtime and make it persistent either. It's just like the workability of that thing is just very complex, and people are just like finding it a hard time to work with it. But I guess, Drew, maybe you have actually tried it in practice to do overlays. Does it work for you?
Yeah, so I mean, the initial kind of overlay work was done by Pantelis for the BeagleBone capes. And, you know, it did work for us, but after it became clear it was never going to go mainline, and uboot got the capability to do overlays, we switched over to uboot. The downside there is it requires a reboot, and can be a little bit more complicated for some of our users to figure out how to do stuff in uboot versus just during runtime itself.
Yeah, I see. So it also for me was recently surprise invention that ACPI in this sense is a bit ahead of device tree, because we have kind of overlays in the networking, and you could load and load many times at runtime. The only problem we already discussed like a couple of years ago, 3 years ago with Linus, that ACPI misses one stuff for pin control, namely this layer between ACPI-CA and pin control subsystem. So we have already everything in spec to support the pin control states, but we miss implementation.
Yeah, so my first thought was, if you have a way to load the device tree overlay, then the pin control stuff, that works automatically. The biggest issue there is to load the overlays dynamically and get that supported upstream. Technically, it works. It's dangerous. You have to know what you do. But yeah, that's the case for many things. The way forward there, I think, is to get into this connector way of having overlays, which is some more like a limited subset where you define how a connector looks like. BeagleBone is probably a bad example there because it's way too complicated. But I think a good starting point would be PMOD connectors or SparkFun Quick or Seed Studio. What are they using these? I can't find the name right now. This 4-pin connector, which you can use as UART, I2C, or GPIO. So those are small, limited examples, and probably good starting points to start defining connector interface. And then later that can be enhanced to BeagleBone, which is more complex, or to the connectors we have on the Renaissance boards where I'm using overlays. Now in real life, most people won't need overlays, and I think, well, I mean, won't need dynamic overlays, and just doing it in the bootloader is probably fine. Who is doing hot swapping of hardware? Recently, I saw a video where somebody was hot swapping Kickstart ROMs in his Amiga, but these are not typical use cases.
Gentlemen, sorry for interrupt. Just so you know, the session already over time for 7 minutes. But this is the last session of this track, so I'm okay to put it open. But consider all the attendees' time. I suggest you can cut it short.
Yeah, people are free to drop out, of course. But
yeah.
I think that one of the things that would be typically counter to doing overlays in the U-boot would be if users have an expectation to actually remux pins at runtime. And one typical use case example of that is people using the Arduino and want to have like their own computer act as an Arduino, because that thing does remux pins on demand at runtime. So if you have an Arduino connected over USB, you expect it to be able to change that pin from GPIO to PWM to UART, whatever, just with a little bit of program code in your little IDE that you have. And I understand it if these users will find it frustrating that I have all of these things in my computer that I'm sitting at, but I'm not allowed to change it. Then I have to reboot it and go into this funny overlay thing. And like, what is this? I understand that to them, coming from that world, this is gonna seem alien. It's not their normal use pattern, let's say.
Yeah, but you see the difference is Arduino is operating system less platform. It's small and like microcontroller. But here we have really operating system and the user's device connected even to USB, whatever. It's not the same thing as a standalone Arduino.
I mean, I think for the use case of us was just for people doing rapid prototyping, which is kind of a narrow use case, but important for a dev board platform like ours.
Yes, and we discussed here at Intel also the possibility and become, if name Mika Westerberg says to you something, then we discussed with him and become to the idea that it's really for prototyping. It's not really needed debugfs or something. It's a bit dangerous because people could use that debugfs and really fry their boards with a real smoke out. And who to blame for that, right?
Right. Yeah. I guess in this case, the facility I wanted to see, all I really want to be able to do is do like pin control select state from user space, and those states are already defined in the device tree. So for a given pin, like on our expansion connector, it might be like GPIO in, GPIO out, or PWM, and the ability to do a runtime pin control select state from user space is really what we want, because we have this utility called config pin, which allows people to say config pin, the name of the pin on the expansion header, and the state that they want it to be in. And the states, it's a defined list of possible states for each pin. So I think the safety for that can be satisfied by the fact that we only have states defined in the device tree that we know are safe for each pin on the expansion header. I mean, I suppose people could potentially create shorts, but in practice over the last like 7 years, that's not been too much of a problem. The main problem here is just that we have this out of tree module, and we'd love to be able to get rid of it while still keeping the same prototyping experience.
I would say go for debugfs for now and see where that takes you. What we could think about in the long run is like, because what you describe is not applicable to all kind of hardware. There are many pin controllers out there that do not control maxing on a per pin granularity. They do it like you change something and you switch the function of 40 different pins. So then this is obviously not going to work. So I would say like take this, and then for the future, if we want to create something generic out of it, it would be more like on the basis like take this, and this pin and expose that to debugfs knob or sysfs knob or configfs knob, whatever knob you have, but so that we can put a policy on what exactly pins we want to do that with and not, so that we just like these are experimental pins. Those you can switch between PWM and UART and whatever. Those pins over here, we don't touch those, like something like that. But those are just like guesses right now. I would say keep it to the debugfs for now.
So could you rule out that this is going to become part of the GPIO version 3 ioctl interface?
I would think it would be something different. Just
Okay.
so at least, you know, divide and conquer, normal Machiavellian tactic.
No, I was just thinking that if there's a chance that it would be part of the ioctl interface, then maybe we should think about it some more and delay the version 2 API one more release before we have come to
I don't think like this isn't really related to GPIOs. Like this is really something separate, and this lives in pin control, and GPIO is really limited to GPIO.
Well, I understand that there are different subsystems in the kernel, but to a user, there is a certain commonality because a lot of the things you're managing are the same pins. Like you might be managing them as pins and set them to high and low, but you might also want to set that pin to do something else.
It is true that I have toyed at times with the idea that eventually far down the road, the GPIO and pin control would become one subsystem and just like do everything related to pins and IOs and so on. It's just a problem right now. That's off in the future with, you know, fusion reactors and flying cars and this kind of stuff. It's like just too far away right now.
I would like to add that for debugfs, like Linus, you were worrying about a group of pins, but we already have this idea of functions and groups. I guess we could only operate on this level. At least it would be more generic-ish.
Yeah, that would be my stance as well. It's just the single pin control people will disagree with me. So I already know what kind of resistance I would meet.
Drew, on that note, I just have a quick question. Is there any support for the BeagleBone kernel in Yocto, for the BeagleBone kernel and the associated tools like the Cape Manager, the PinMax helper and all that? Is it on like a really Debian specific, or is there some support for that in Yocto?
It's not Debian specific. I'll put the link in the chat. We have a directory of patches that we apply to our Debian kernel, but it could be applied on top of any of the kernels. We tend to rebase our patches for each of the stable kernels that TI does. So right now that's 5.4, and the work I do is just on top of mainline. But we stopped using the overlay Cape Manager though, the Cape Manager, which was a MIST driver. So kind of the main things are right now is this Bone PinMux helper, and there's another one called GPIO OF helper, though I think I can solve that by using aggregator. But I'll drop a link to our patches into the chat here. Mainline does boot. It's basically just some of the out-of-box features that we use for like our tutorials don't work, mainly the config pin utility.
Okay, yeah.
But there are lots of people that use Yocto to run on the BeagleBone, especially when people go and like make products out of it. They tend to stop using our Debian image and switch over to Yocto. Or
yeah, this is what I'm thinking about, and like the kernel from MetaTI doesn't support any of that. So I was thinking that maybe it would be easier to just reuse these tools in Yocto.
Yeah,
but this is not related to this talk. I don't really want to take your time with this, but we'll take it offline maybe, or.
Yeah, definitely we can talk about it. MetaTI, I mean, the main things that are out of tree that matter a lot are the stuff for the PRU, because it took TI a really long time to upstream support for the PRU. For those that don't know, there's these little microcontrollers that are in the SoC that the BeagleBone uses. And they finally got the remote proc driver, I think, upstream just now. So for all the past years, we've been using that from the TI kernel. So that's kind of the main thing that's missing from mainline, is to use those PRUs. But other than that, there's not a lot that's not mainline. I mean, the other thing too is the SoCs, I think 10 years old by now. So most of the support's in there. It's just these rapid prototyping use cases that aren't really covered yet.
Guys, to the topic, I have also a question about ARM64 and ACPI. Is GPIO somehow in pin configuration considered to be there?
For ARM64, I'm not working on any ARM64 system that has ACPI, so I don't know.
I think generally speaking, those would be for servers where you don't want to configure the pin mux or the GPIO. I think in the past, we've always said that pin muxing and pin control would completely be out for those systems. GPIO you might have, because you can always have devices that have GPIOs exposed to user space. But that would just be a regular device somewhere that happens to have some GPIOs.
Yeah, but what I mean, this ACPI specification provides pin configuration. For example, firmware could use some pins on their own purpose before system boots, and system switch it to different purpose by some reason. And for that, you have ACPI description for pins. So if you would like really through ACPI as well, switch device, even on servers, it could be possible. And from experience, I could tell that our customers, they use GPIO on servers, which surprises to me. But
Oh, we did have one question from Aaron. I don't know if you're still interested, but you had asked about the Virtio based GPIO driver.
Right. Yes. Since we're adding Virtio drivers for almost anything now, that is something I was wondering whether there's already work going on for that and how it connects to the host side.
I see this question from Lucas about creating a connector device with a GPIO aggregator. So yeah, if you have a connector, a physical connector that is only GPIO pins, then you can use the GPIO aggregator to group them all together into one virtual GPIO chip. But the whole connector thing would be more generic. So if it's just GPIOs, it's not that interesting. It's more interesting if some of these pins can also be used as the I2C or UART bus. And then you want a way to expose that and describe users that are connected to them. But if it's purely for GPIO, then yeah, the GPIO aggregator can help there.
Okay. I think
I hope that answers.
I think I pasted the wrong your comment about echo pin mux into debugfs. That was unrelated, right?
Indeed.
Okay. And did anyone have a reply to? I guess Linus replied about not having seen any of the Virtio GPIO stuff, but he'll relay the question to Bjorn. Anyone else have any final
Yeah, for
thoughts?
Arndt's question. So basically, I worked on adding support for GPIOs to QEMU. So I have something for outputs. It wasn't welcomed that much. And I didn't use some Virtio protocol because basically the GPIO ship device in user space is already good enough for that, I think. So it's not needed to define some other protocol. So yeah, using that, I can control LEDs on the board from QEMU. So far, it's only outputs, but not inputs yet.
Mm-hmm. Yeah, the idea about Virtio would be to make it more generic across different kinds of hypervisors and virtualization and emulators and all kinds of other things. Like they might, we're adding Virtio drivers for other things too, where you might have the console routed through Virtio to some other hardware device, for example, and have that run on a microcontroller somewhere, and same for GPIO. So they might just be somewhere completely different. So Virtio is the logical thing for that. And then you can also have it in user space, have the host side running as a separate process and not implemented as part of QEMU, but QEMU could just route the Virtio channel into user space.
I actually remember having that discussion with Alistair from Google, because they have this, Android emulator thing that they want to run, and they have like Virtio for GPU and PCI and whatnot, like that they have on the phone. And I asked him, do you have some plan for something you want to use? And I involved them in review of Gert's series. And their stance from Google Android's point of view seemed to be pretty much like, we don't know. What do you guys think? So that's their point of view. If we want to drive people towards Virtio, we can probably do that, but not that Google Android for sure. They just like use whatever we want them to use.
Yeah, most Android phones don't have external GPIO lines that you might want to control.
Mostly not. Some do.
They may have internal lines we want to control.
Yes.
Yeah,
But you could
the thing here is
also
they are using it in the emulator to like test out like a mobile phone mockup. So they have like a piece of hardware that is like somewhat in reminiscence of the phone that they want to use in the end, or like something in a use case direction of something they want to use, and that has a bunch of GPIOs on this like hardware mockup.
Well, the thing that could actually happen is that we would see a Virtio-based GPIO pin control driver that controls, like that is just generic to a lot of different phones, and then you have the host side of that implemented either in a hypervisor or in secure world running in a separate context and actually talking to the hardware, so that you don't have to write a new driver for every single SoC that comes up, but just have the abstraction at a different layer. I think there's a desire to have that, even though it has a lot of disadvantages too.
I agree. Yeah, it's just like I kind of nudged Google to go and do that. Just implement it, please. But well, they didn't wanna, so.
Awesome.
Okay,
Anyone
guys.
else have any?
Yeah, did
Pardon?
we exhaust the discussion?
Anyone else have any final thoughts or questions? If not, we can wrap up this extra serving of GPIO pin control.
Thanks, guys. Nice talking to you.
Yeah, Thank you all. I did apparently have the slides link not public, so it should be fixed now. So if anyone that wants to, you can click on the slides link in Slack there, and I'll add them to the Sched page as well. But thank you for everyone for joining and chatting, and see you all on the Slack.